Okay, so today we're going to talk about some techniques for using logs to solve equations. The first one we're going to do is logging both sides. So sometimes you have an exponential situation like this where you're trying to solve, and it's not there's no common base between 3 and 600, so we couldn't rewrite it. So what we'll do instead is we'll log both sides of this. So it will be rewritten as log of 3 to the 5x equals log of 600. And the reason we want to do that is now I can use the log laws to take that power, that exponent, and move it to the front. So by doing so, now I can solve this for x. It's just regular multiplications here. So I have log 3 and log 600. Remember, these things that's one thing. Even though there's a whole bunch of stuff written there, that's it. Just got to think of it kind of like it's indestructible. Unless you rewrote it as an exponent, there wouldn't be any way of pulling this apart. So that's one number right there. The calculator is going to tell me that number. I don't know that number off the top of my head, but just going to rearrange that. So it would say 5x equals log 600 over log 3. So x would be log 600 over 5 log 3. And of course we need a calculator for that. So my calculator says that this is 1.165 to 3 decimal places. Okay, so I'll get you to try those two. The next ones that are here using the same technique. So log both sides, and we'll review together. So you may want to pause it here and try those, and then I will review them with you. Okay, so for this one, there's nothing wrong with going like this, doing what you would normally do with your equation and divide both sides by 2. If I log this, I can now move the exponent to the front. So x will be log 150 over log 3. And again, get a calculator to help us out here. So 150's log divided by 3's log. I get about 4.561. Okay. And again, on this side, there's going to be a little bit more algebra to do because I've got variables on both sides, but it's going to be the same process. Log 5 to the x equals log 9 to the x minus 2. And remember, this is one exponent here, so that whole thing is going to be moved to the front. So this will now become x log 5 equals x minus 2 log of 9. And to start working with the x by itself, I'm going to have to distribute these to get it by itself. So that'll become x log 9 minus 2 log 9. And it's like anything else. Remember, these are just numbers. So what I want to do is move my x's to one side, and I'll have x log 5 minus x log 9 equals negative 2 log 9. Now I can factor my x's out, so it'll become x log 5 minus log 9. And again, it looks really strange, but remember, this is a number your calculator is going to tell us. So all we're going to do is divide. We're going to have x equals negative 2 log 9 over log 5 minus log 9. So that's about the worst that they get in terms of the algebra you'll have to do, but the process is still the same, rearranging, and of course we need a calculator for this. And my calculator gives me 7.476. Okay, so hopefully you were able to get the same ones. Now, another technique that we're going to talk about here, the common base rule for logs. This one is one we're going to use quite a bit here. That means if we have a log base a that's equal to another log base a, the only way that could be true is if those two things are also equal. Okay. So I'm going to show you an example here that kind of makes it sort of seem like it makes more sense. So for example, in this one, log base 7 of x equals, I'm going to use the division law here. So that's the same thing as log base 7 of x equals log base 7 of 5. So, I mean, it's almost common sense that if you got the log base 7 here and here, the only thing that differs, those two have to be equal in order for this whole thing to be equal. So x would have to be equal to 5 in this situation. So it's not always going to be nice numbers like x equals 5. Quite often it will be, but you know, we may have situations like this where we have to deal with a little bit of rearranging. So for example, I could do this as log x equals log 0.2 plus log 1.5. Log of x equals, so 15 times 0.2 will be the multiplication law, and that means log of x equals log of 3. So again, that means x must equal to 3. Okay, another situation that we might encounter, maybe one more creative step to work with here. This time, I don't have just the one logarithm. What I could do is move these together. So I could go x plus 1 and I still don't have the same pattern of log base 5, but I could rewrite one as log base 5 of 5. So what that now means is this must equal this. So we have an equation that would be x plus 1 times x minus 3 should be equal to 5. And of course, we're going to have some quadratic equation to work with here. So it'll be x squared minus 2x minus 3 equals 5. And if I rearrange that, that'll be x squared minus 2x minus 8 equals to 0. So I think that'll be x minus 4 and x plus 2. So that means x equals 4 or negative 2. Now, one thing before we circle that as our final answer, remember we had restrictions on the log function. So there's some things that we said, like the base has to be greater than 0 and cannot equal 1. And the domain has to be greater than 0, meaning whatever I stick inside that logarithm function, that has to be a positive number. So if I think about what I've got here, 4 won't cause me any problems because 4 plus 1 equals 5 and 4 minus 3 equals 1, both positive, so 4 is going to work. But if I try this with negative 2, then negative 2 plus 1 is negative 1. Negative 2 minus 3 is negative 5. Neither of those work. If just one of them didn't work, the answer wouldn't work. So we have to reject that. The only one here that works as an answer is x equals to 4. Otherwise, we violated this rule here that the domain is greater than 0. Okay? Just to show you another quick alternative way we could have solved this one, I'm going to get rid of this. And an alternative way we could have done it is we could have said, just like we did before, use the product rule to combine these. We could say at this point, well, we could also rewrite it as an exponential. So this is another convenient way to try to solve the equation, because now the logs have also disappeared. So that's really the goal when we're solving, is we want to figure out how do we get the logarithms out of this equation so that we can try and solve it without a calculator. And again, this would give me 5 equals x squared minus 2x minus 3, and we'd end up with the same x minus 4 and x plus 2. So x would be equal to 4, negative 2, we would reject that one. So it would be the same way, but this is the difference in step, is that if you prefer, and usually that's the way I prefer to solve it, in this situation you can rewrite it as the exponential. So just you probably try using both ways in this lesson just so you get a hang of them. But let's take a look and see if we can figure out what the mistake is in the example below. So I'm going to let you take a look at it for a minute, so you probably want to pause it, and then we'll illustrate where the mistake was made. Okay, so hopefully you've had a chance to maybe dig this through and look at it. This is in log base 2 for all of them. So we can use log laws on this. However, one mistake that's been made is that this was addition. It does not work that way, remember, when you use the log laws. What should have happened is, at this point, everything kind of went wrong. You can't just drop the logarithms out of the equation. And that's something that students do, is for some reason they see this log 2, log 2, log 2, and they go, oh yeah, I remember Mr. Joyce said get rid of all the logs. But you can't just get rid of them. You have to manipulate the equation until it does it properly. So first, I'd have to go like this. And now I'm in a situation where I have a single logarithm and another logarithm. So both are in base 2. The only way that those two things can be equal is if this equals to this. So that's where I should have stopped this to say x plus 4 times x minus 5 would be equal to 7x. Okay, so remember, you can't just drop the logarithms. You actually have to use the log rules appropriately. So this would be, let's see here, minus x plus 20 equals 7x. So x squared minus 8x plus 20 equals 0. Let's see here. So I think we could factor that with minus 10 and x plus 2. So I'd have answers of 10 and negative 2. Okay, so we're on our way then, right? Okay, be careful though, because remember, we just talked about this. It's going to be something you have to keep in mind. We have to go back to where we started and say, do these answers make sense? So for example, does 10 make sense if I substitute it in here? Yep, it's okay. 10 plus 4 is 14, no problems. Does it make sense if I substitute it in there? 10 minus 5, yep, still positive, no problems. And finally, if I substitute it in there, no problems. 10 times 7 is, it's a positive, it's 70, so 10 will work. But we've also got to check, will this other answer of negative 2 work? So if I put in negative 2 here, negative 2 plus 4 is positive 2. So that's okay in the first example. Negative 2 minus 5 is negative 7. So at this point I can stop. As soon as it failed on one of them, it won't work for the rest. Okay. Now, at this point I should warn you, it's not just going to be the case that because it's negative, it won't work. There could be times when the negative answer works, but the positive answer doesn't. Remember, you have to take the answer, go back to where you started, and ask yourself, would it be possible to use that answer? Okay, not because it's negative you're rejecting it, it's because when I use it, it causes a problem. Okay, so I'll let you take a look at this one, and we'll see if you can figure out what the mistake is, and then we can unpause it when you feel like you've got an answer. Okay, so hopefully you've had a chance and you could figure it out. Here's the problem right here. According to the log laws, this equation should become log of x squared equals log of x squared plus x minus 12. That exponential rule has to come up before these two things are equal. There's more than just a log and another log here, right? There's an extra piece, there's a 2. So now I'm in the situation in this spot where I have just a log and another log, so these two pieces must be equal as well. So x squared must be equal to x squared plus x minus 12. So if I rearrange this, looks like x is going to be equal to 12. Okay. There's another problem with this person's work. If we looked a little further, you'll see that 4, if I substitute 4 in, no problem there, and no problem when I substitute it in there. So 4 is good. But there's also a mistake here that -3, well, it fails right on its first try. If we try to put a -3 in there, it won't work because a logarithm can't be negative. So that means I have to reject this. So had that actually been the answer, that's another mistake the person had made, is you didn't check their answers. Okay. If we look back at our answers, 12 is going to be fine when I put it into both of those. So yeah, 12 will work. So I'd like you to try solving a couple on your own. You should pause the video here and then take a look at my work against yours. Okay, so hopefully you've got your work. You can check it over against what I've got. So I'm going to use the log law for multiplication first. And now I've got log base 2, log base 2. So that means I could rewrite this as x minus 2 times x equals to 3. So x squared minus 2x equals 3. X squared minus 2x minus 3 equals 0. So x minus 3 and x plus 1 equals to 0. So my possible answers are x equals to 3 and -1. And if I try 3 minus 2, yeah, that works. That works. So 3 works. But if I try -1, it's not going to work in there. So the only answer I have here is x equals to 3. Okay. And in the next one here, so if you haven't finished the second one, you probably want to try that before you see what I've done. So you may want to pause it. Log x minus 1 times 2x minus 3. Now I've got just the logs and nothing else, so I can rewrite this as x minus 1 times 2x minus 3 equals 2x squared minus 5. And if I expand that, 2x squared minus 3x minus 2x plus 3, 2x squared minus 5. So let's see here, those 2x's will disappear. If I collect like terms, -5x, let's see here, equals -8. So x would be equal to 8 over 5. Okay, so let's try these then and make sure that they still work. So no problems if I take 1 from 8 over 5. This time, if I go 8 over 5 times 2 and take 3 away, I end up with 0.2, or 1/5, so that still works. And if I go 8 over 5 and I square it, and times it by 2, take 5 away, I get 0.12. So positive for all the numbers, that will work, and that is a proper answer. Okay, so before we continue, you may want to review a little bit of your factoring skills. For example, you should always take the greatest common factor out before you try to do some of this factoring. So as you've already seen, factoring is going to be a big part of solving these questions. X plus 1, x minus 4 will factor here, so we could solve it if we needed to go beyond this. But there's other ways of doing these, and the way that I usually teach students a shortcut to factoring, there are several, but the one that I like to use is this one where I multiply out the first and the last term, and I factor the piece that I have. So this piece will be x plus 4, x plus 3. And because I did this multiplication up here, I'm going to do a division to try to balance this equation out. And I can't reduce that fraction anymore. So I can rewrite this as x plus 2. And that 2 that is on the bottom will go to the top as 2x plus 3. And if you FOIL this out and check, you'll find that this is actually the factored form of the one that's up there. Okay, so again, if you use that little shortcut that I like, factoring these out, x squared minus 19x minus 20, that's an easy one to factor. Remember, there's a multiplication that changed things, so I need to do a division to help balance this out. That's going to give me x minus 5 and x plus 1/4. And I can't reduce that anymore. So that's going to make this 4x plus 1 when I move that 4 up to the front. And again, you'll find that this is the factored form of the original. So on my website, you'll find I've done some PowerPoint examples of some couple animations of this. So if you'd like to see some more, you could try that by going to my website. But these next examples are going to require that you use some technique of factoring when there's a number in front, like the 2 or the 4, or maybe it'll be nice enough that it's just a greatest common factor. But you should pause it here and try doing these examples, and then I'll catch up to you and you can compare your examples against mine. Okay, so I'm going to move one of the logs over, because now I end up with a product rule instead of quotient. And I think it's easier to talk with the multiplications than to deal with the fractions. You don't have to, but this is one possibility. And remember, this is the log in base 10, so you could do this two ways. You could rewrite this as the log of x plus 4 times 2x equals log of 10, or you could do this as the log of x plus 4 times 2x equals 1, and rewrite this in exponential form. So that's base 10 to the 1 equals x plus 4 times 2x. Okay. So again, these are equal because log base 10 is 1, and this one is also equal over here because I've just rewritten it as an exponential. So if I was to multiply this out, I'll get 2x squared plus 8x, and there's a greatest common factor here, so I should try that first. And that I can factor as x, let's see here, so that'll be, let's see here, plus 5 and minus 1. So I would get answers that are x equals negative 5 or positive 1. So negative 5 is not going to work in either. Won't work there, won't work there, rejected. Positive 1, yeah, no problem there, and no problem there, so positive 1 will work. That's the only answer in this situation. Okay, for the next example, I'm going to do this in a similar way. But I'm going to start doing it, as I mentioned earlier, I prefer to just rewrite as an exponent. So I'd go 2 cubed equals 3x plus 2 times x minus 1. So 8 equals 3x squared minus 3x plus 2x minus 2. And if I collect my like terms, and again, you're free to use any technique that you like. I'm going to go with the one that I use, which looks like this. And that'll be x minus 6, x plus 5, and I got to divide by 3. So I get x minus 2, and I can't reduce that one, so it's going to become 3x plus 5. So my answers could be x equals 2, or negative 5/3. Okay. So if I check on these answers, let's see, well, clearly this one's not going to work when I put it in there. The negative, take away negative, still going to be a negative number. But the positive 2, that will work in both this one and this one here. So x equals 2 will be my answer. Okay, so let's try finding the mistake again, now that we've tried some of these, this one more like what we've just been working on. So see if you can find it this time, and you may want to pause it and I'll show you where the mistake is in just a minute. Okay, so if we take a look at the way this one has been worked, the problem occurs, well, basically the first step, things go wrong here with the way the log laws were applied. So when you think about your order of operations, this multiplication is going to happen before this addition. What the person here decided to do was the multiplication first, and they combined 2 and x to get this. So what we should have had happen was we should have rewritten this as log x squared plus log 2 equals log of x plus 3. And now we can combine them using the log laws. And at this point, this is set up now so that we can drop the logs from both sides. And we can start factoring. So I end up with factors that look like x minus 3, x plus 2, and I've got to divide both sides here. So I'll have x minus 3 halves and x plus 1. So 2x minus 3 and x plus 1 to be equal to 0. So I end up with possible solutions of x equals 3 halves or negative 1. And right away I can reject negative 1 because there's going to be a problem with this part of the equation here. So let's just say forget about that. If I look at 3 halves though, 3 halves is going to work because there'll be no problem adding 3 halves to 3, no problem putting it in there. So that would be the correct solution. So another thing that we may end up coming across is you may end up coming across something like this, where when you combine things, you end up with a fraction. So just for a bit of practice, we'll try doing a rational equation. Okay, so at this point, again, I'm in the situation where I have just log and base 4 on both sides, so that means their arguments must be equal. So I can cross multiply here. X plus 1 will be 8 times 2x minus 3. So we'll have to keep working up here. X plus 1 equals 16x minus 24. And if I combine my like terms, negative 15x equals negative 25. So x is negative 25 over negative 15. And we probably reduce that to 5/3. So if I check with 5/3, I don't believe there's going to be any problems here. It'll work in this one, and that'll be fine as well after I substitute it into there. So 5/3 would work. And of course, if you don't like working with fractions, we could also approach the equation like this, and it would work just the same. By moving the negative to the other side. So what I could do is take this part of the equation, this negative, and say I don't want to work with fractions, so I'll move it to this side so it can become positive. That also works because you'll notice I won't resolve the whole thing, but I'll show you the point at which they become equal. Log base 4 of 8 times 2x minus 3. So then I'd have x plus 1 equals 8 times 2x minus 3. And again, you can see that this part where I'm at now is the same as this part here. So I won't keep going, but there is that option if you don't like working with fractions. Just think a couple steps ahead. Okay, so finally, try a couple other equations here. So you may want to pause this and see what you can do with your examples in front of you, and then you can unpause it to take a look at the answers that I'll produce here. Okay, so in this one, the pesky problem is this half here. It's kind of like, how do I work with this half? There's no logarithms in it. So I definitely can't do this. This won't work. It's not possible to combine it like that because there's no log here. So none of that's going to work. You got to be a little bit more creative. It would be a lot easier if we had a log in it. So that's what I'm going to try to figure out, is how could I rewrite 1/2 with a log? Well, what I'm trying to ask myself then is 9 to the 1/2 equals 3, so this is equivalent. The 1/2 exponent is the same as log 9 of 3. Now I can do some combining here, so I'll get log base 9 of x equals log base 9 of x minus 1 times 3. So x equals x minus 1 times 3. And if I rearrange these values, let's see here, negative 2x equals negative 3. So x will be 3/2. And if I look, no problem there, no problem there. It will work out. Okay, and in this one, if I look at my equation, now I'm set up to have just logs, so I'll drop them from the equation. X squared equals 2 plus x times 3. So x squared equals 6 plus 3x. And this is what I'm going to be trying to work with. Oops, and of course I've made an error there. That's not the right log law, is it? Really what I should have had here is I could divide by 3. So this would be 2 plus x over 3. Okay, so my apologies. That means when I cross multiply, this is what I should have. So this might hopefully work out a bit better because the last one didn't look like it was going to factor. So minus x minus 2 equals 0. And that gives me x squared minus x minus 6. Yeah, that looks better. X minus 3, x plus 2. And even things out. So I'm going to get x minus 1 and 3x plus 2. So my possible answers are x equals 1 or negative 2/3. So if I try these in, I mean obviously negative 2/3 won't work in there, so I can get rid of it right away. But 1 won't have any problems, so 1 definitely will work as an answer.